Good morning, students. In the previous class, we have studied about what are different types of numbers, and we have come to what are rational numbers and what are irrational numbers. So now we all know what are rational numbers and what are irrational numbers, right? So now, keeping this in mind, let's look at how to look at a number and identify whether it is rational or irrational, okay? That is our main purpose now. Now, for that purpose, we need to know what are perfect squares, okay? Now let me start. What are perfect squares? Some of you might have the knowledge of what are perfect squares and some of you might not have the knowledge of what are perfect squares. So let me start with explaining what are perfect squares. Now look here. 36, 49, 4, 9, etc. Can you look at these numbers and find some speciality about these numbers? Something common about these numbers? Just think. Now, some of you might have already thought, some of you might have already got about what the similarity between these numbers are, and some of you might be confused. Now, let me explain it to you. Look at these numbers. These numbers are squares of some numbers, right? These numbers are what? These numbers are squares of some numbers. Like 4, for example. 4 is the square of which number? 2. 2 square is 4, right? You must know what are squares and what are cubes, okay? You must study the squares and cubes of at least till 20, okay? Because you're in class 9, you'll be using the squares and cubes everywhere, almost everywhere. So please make sure that you know the squares and the cubes of numbers from 2 to 20 at least, okay? Like 2 square is 4, 3 square is 9, 4 square is 16, etc. Or 2 cube is 8, 3 cube is 27, 4 cube is 64, etc. Okay? So these things you need to know till from 2 to 20. Make sure you know all those, okay? Now keeping that in mind here, 2 square is 4. Likewise, 9 is which number square? 9 is 3 square, right? 49 is which number square? 7 square, right? So likewise, 36 is which number square? 6 square, right? So a number which is a square of some other number is called a perfect square. So what is a perfect square? A perfect square is a number which can be expressed as a square of some other number. Like 4, 9, 36 and 49. So 4, 9, 36 and 49 are what numbers? Perfect squares. Okay, so what are perfect squares? Perfect squares are those numbers which can be written as the squares of some numbers. Okay, so that is what perfect squares are. So now, keeping perfect squares in mind, let's see how to identify a given number, whether it's irrational or rational. Okay, now look at these numbers. Now, I've taken some random numbers. First, I've taken in order to show you, and then I've just taken some few numbers from between because I cannot write all the numbers, right? So I'm taking some few examples just to explain this to you, okay? Now look here. Look at 1. Is 1 a perfect square? Yes, 1 is a perfect square. Now, how do we know that 1 is a perfect square? Because 1 can be written as 1 square, right? 1 can be written as 1 square. So that means 1 is a perfect square. Yes, it is a perfect square. Okay, let's identify the perfect squares, alright? 2, is it a perfect square? No, it is not a perfect square. 3 is not a perfect square. But 4 is a perfect square. 4 can be written as what? 4 can be written as 2 squares. So 4 is a perfect square, right? Now 5, is it a perfect square? No, it is not a perfect square. 6 is not a perfect square. 7 is not a perfect square. 8 is not a perfect square. Likewise 9, 10, 11, 12 are not perfect squares. Now look at this example. 16, is it a perfect square? Yes, it is a perfect square. 36, is it a perfect square? Yes, it is a perfect square. 37, is it a perfect square? No, it is not a perfect square. 100, is it a perfect square? Yes, it is a perfect square. Now what is the identifying whether these numbers are perfect squares or not. Look here. 1 is a perfect square. That means I can remove the square root and I can write this as 1. Right? 4 is a perfect square. That means root of 4 will be what? 2. How did I get that? Now look here, refresh your memory. You already know these things. Look here, refresh your memory. 4 is equal to 2 square. Right? Now square goes to the other side is equal to, what does it become? 2 will remain there itself. Only square goes and it becomes square root. Right? Square goes to the other side of equal to, it becomes square root. Right? So 2 is what? Square root of 4. So square root of 4 is what? 2. So that means square root of 4, I wrote it as 2. Right? So likewise, can I look here? Which one is the perfect square? Next one? 16 is the perfect square. So can I, instead of writing root 16, can I write 4? Because 16 is 4 square, right? And 36 is what square? 6 square. So I can write square root of 36 as 6, right? Now, 100, which number square is 100? 10 square is 100, right? So what is the square root of 100? When the square goes to the other side, it becomes square root, right? So it becomes square root of 100. So what is left? 10 is left. So that means square root of 100 is 10, right? Square root of 100 is equal to 10, which means instead of square root of 100, I can write 10 here, right? So can you see that only perfect square numbers are the numbers without root, right? Only perfect square numbers are the numbers which can be written without root, because the root cancels with the square, right? And every other number has to be written inside the root. Why? Because they are not perfect squares, right? So that means from these type of numbers, I can identify what are irrational and what are rational numbers. Now look here, very carefully look here. All those numbers, okay, which are perfect squares, okay, are rational numbers, okay, and the their square root are all rational numbers. Okay, what did I say? Making it clearer. All the numbers which are perfect square, okay, if you take their square root, you will get rational number. Okay, that means the opposite of it is what? Irrational number. Okay, what is the opposite of it? All the numbers which are not perfect squares, if you take their square root, you will get irrational numbers. Okay, all the numbers which are not perfect squares, if you take their square root, you will get irrational numbers. Okay, so that is how we identify which one is rational and which one is irrational numbers. Okay, so now let me show you some more examples to make it clear. Look at this, root 12. Is it a rational or an irrational number? Is it a rational or an irrational number? 12, is it a perfect square? It is not perfect square, right? 12 is not a perfect square, right? So since 12 is not a perfect square, the square root of 12, this number, square root of 12 is irrational. Did you understand? Square root of 12 is irrational, right? So likewise, let's see some few more examples. Square root of 64. Is it rational or irrational? Now, you know that 64 is what? 64 is 8 square, right? 64 is 8 square. So, how can you express this root 64? Root 64 can be written as root of 8 square, right? Now, the square root cancels itself, and what can I write? 8, right? And 8, how can I express this 8? 8 can be expressed as 8 by 1 or not? Any number by 1 is that number itself, right? Any number divided by 1 is that number itself. So 8 can be written as 8 by 1, right? So now can I say that this is P by Q form, right? And Q and P are both integers. 8 and 1 are both integers, right? 8 and 1 are both integers, and this 1 is not equal to 0. 1 is not 0. So that means this number, this root 64, 64, I can write it in the form of P by Q. Right? Root 64, I can write it in the form of P by Q, where P and Q are both integers and Q is not 0. So can I say that this is a rational number? Yes, it is a rational number. Why? Because we can write it in the form of P by Q. But without doing any of these, just by looking at root 64, itself, I know that this is a rational number. How do I know? Because of the method that I taught you. What is the method that I taught you? When you look at this number, if it is a perfect square, that means it is rational, right? If it is not a perfect square, that means it is irrational, okay? For example, root 63, I know that this number is not a perfect square. So root 63 is what? It is an irrational number, okay? It is an irrational number, okay? So now you know how to identify what a rational number is and what an irrational number is, okay? So, keeping this in mind, let's look at one special irrational number called pi. Okay? You have seen pi. We have used pi when you study circles, right? When you study circles, we use pi everywhere, right? It's involved in the formula of an area of a circle, of the circumference of a circle, etc. Right? Now, if you don't know what is the area of a circle, what is the diameter, what is the radius, what is the circumference, etc., or if you don't know what are the specifications of a circle, then please Google it or please watch some video and learn it, or please take your younger classes textbooks and please learn it, because we have been studying circles from almost class 7 onwards, okay? So please take one of these books and learn about circles, okay? So now, in circles, you know that you will come across this symbol, pi, right? Now what is pi? Pi is the circumference by diameter of any circle. Now for example, if I take this circle. Suppose I have taken this circle, okay? What is the diameter of this circle? The line which joins one point to another point, and this line should pass through where? Through the center of the circle, right? This is not a perfect circle, but imagine a perfect circle, alright? So now, this is the line which passes through the center and it connects to endpoints, right? So this is the diameter of the circle, right? So now, the distance from one point to another point inside the circle, and that line passes through the middle or through the center of the circle, right? So this is the center of the circle. So this is the diameter of the circle, right? This is the diameter of the circle. And what is the circumference of the circle? Circumference is, if I take this point, then the length from here to here, okay? The length from this point to this point. Now, if I open up this circle and put it here, will I get a line, right? If I open up from this point, if I cut this circle from this point and put it here, I'll get a line, right? So if I measure the length of this line using a scale, then I'll get the same measurement, okay? So this measurement is called the circumference of the circle, right? So that means, look here, what is the formula of circumference? You need to know all these, okay? 2 pi r. These are all done in your lower classes, right? And what is the diameter? Diameter is d, right? Now, what is the diameter? Diameter is radius plus radius. So I can write 2r, right? So I can write 2 radius. All these things, lower classes, you already know, okay? So 2 pi by 2r, which means, look here, pi is a number, okay? Pi is a number that you get when you divide the circumference of any circle by its diameter, okay? Now, why am I explaining this to you in the middle of number system? Because pi is a special number. What is the specialty of pi? Pi is an irrational number, okay? This is a universal fact and you need to know that, okay? Pi is an irrational number. Now let's look at why pi is an irrational number. If we find the decimal expansion of pi, we will get 3.141592653, etc. We go on, okay? So what type of decimal expansion is this? This is non-terminating, right? Non-terminating. Can you see that it's terminating anywhere? No, it's not terminating. So it is non repeating, right? Non-terminating and what? Any digit, any sequence of numbers, do you see it repeating? No, none of the sequence of numbers is repeating. 1 is repeating here, but after that again 1 is not repeating here, again 1 is not repeating here, right? 4 is here, can you see any more 4s? No. 5 is here, but 5 is here after 3 numbers. Now after 3 numbers, if you check, 5 will not be there. Which means none of the numbers are repeating in a sequence. So which means I can say that this is non-terminating, non-repeating, non-repeating type of decimal expansion. Okay. So pi is the value that you get when you divide the circumference of a circle by its diameter, okay? And every time you divide the circumference by the diameter, you get this value. For any circle you take, you'll always get this value. And this value is what type of value? This is a non-terminating, non-repeating decimal value or decimal form, right? So that is why pi is an irrational number. Why? Because we have already learned that an irrational number has non-terminating, non-repeating type of decimal expansion, right? So pi is an irrational number. Remember that, okay? Now, based on all of these that we have studied, can we conclude that we have already known, we have already known that rational numbers are what type of numbers? Rational numbers are all those numbers that we can write in the form of p by q, where p and q are what? Elements of z. What does elements of z means? P and q are elements of the set integers, right? Which means p and q are what? Integers, right? So p and q are integers, and one more condition, q is never 0. Q is not equal to 0. That means q is never 0, right? That is one condition. So can I say that irrational numbers? Can I say irrational numbers are all those numbers which are opposite case of this. What is the opposite case? Which cannot be written in the form of p by q. It cannot be written in the form of p by q, where p and q are integers and q is not equal to 0. So it cannot be written. So can you see that it's the complete opposite case? So yes, definitely. Now, after learning all of these, what do you come to know? You come to know that rational numbers and irrational numbers are two types of numbers, right? Which are completely opposite of each other, right? So now, after learning all these, you can identify, you can look at one number and you can identify whether it's a rational number or whether it's an irrational number, alright? And especially keep the case of pi in mind. Pi is an irrational number. Why? Because it has non-terminating, non-repeating type of decimal expansion, alright? So now, keeping all these things in mind, let's go on to our next topic. Look at these numbers, 1, 2, 3, etc. goes on till infinity. Or 0, 1, 2, 3, 4, etc. goes on till infinity. Okay? 0, minus 1, minus 2, etc. goes on till minus infinity, right? And the side 1, 2, 3, 4, etc. goes on till infinity, right? Now, what are these numbers? Obviously, you know from the first class it is natural numbers, right? Now, this one from the first class again, whole numbers, right? And this set of numbers from the first class, you know that it is integers, right? Now, look at these 1. Can I write 1 as 1 by 1? P by Q, and Q is not 0, right? 2 I can write as 2 by 1, right? Because 2 by 1 is 2 itself. Can I write P by Q form, and Q is not 0? 3 again, 3 I can write as 3 by 1. 1 again, not 0, 3 by 1, right? 3 by Q form. So can you see that all the natural numbers, I can write it in the form of P by Q where Q is not equal to 0. So what can I conclude? All the natural numbers can be written in the form of P by Q, right? Where P and Q are integers, right? And Q is not 0. So what can I say from that? That I can say that all the natural numbers are rational numbers. Can I say that? Yes, I can say that, right? Now, likewise, look at this. This is all natural numbers, so which means they are all integers. integers, right? Now special case 0 in whole numbers. 0, can I write 0 as 0 by 1? What is 0 by 1? Any number divided by 1 is that number itself, right? So 0 by 1 is what? 0. That means I can write 0 also in the form of P by Q, where Q is not equal to 0. Even if P is 0, no problem. Q should never be 0. That's the condition, right? So P by Q, I can write 0 in the form of P by Q, where Q is not equal to 0. What is Q here? 1, right? So P by Q and Q is not equal to 0. That means if I can write 0 in the form of 0 by 1, that means 0 is also a rational number, right? 0 is also a rational number. Now look at this. Natural numbers are all rational numbers. I saw that right now. Likewise, whole numbers are also all rational numbers. Why? Because every number can be written as 0 by 1, 1 by 1, 2 by 1, 3 by 1, 4 by 1, etc. infinity by 1, which means what? Every number can be written in the form of P by Q. So these are all rational numbers, right? Now likewise, can I write all these also by 1, integers also, minus 2 by 1, 1 by minus 1 by 1, 1 by 1, 2 by 1, 3 by 1, etc. Minus 4 by 1, minus 5 by 1, etc. So every number in the integer set can also be written as P by Q, right? And Q will never be 0, and P and Q are both integers, right? So can I conclude from all of these that every natural number is a rational number, right? Every natural number is a rational number. Then I can conclude that every whole number is a rational number. This means same thing as that, okay? So every whole number is also a rational number, right? A rational number. And every integer is also a rational number, right? So if you see a statement in your exam, state true or false. Every natural number is a rational number. Is it true? Yes. Because every natural number, 1, 2, 3, etc. can all be written as 1 by 1, 2 by 1, 3 by 1, 4 by 1, etc. So all those are rational numbers, right? Now every whole number is a rational number. That is also true. Why? Because every whole number can also be written in the form of P by Q. How? 0 by 1, 1 by 1, 2 by 1, 3 by 1, etc. Right? Now every integer can also be written in that form. Minus 1 by 1, minus 2 by 1, minus 3 by 1, etc. minus infinity by 1. Then 0 by 1, 1 by 1, 2 by 1, etc. till infinity by 1. So every natural number is also a rational number, every whole number is also a rational number, and every integer is also a rational number. So which means, can you see that all the numbers that you know up until now, it is either rational or it is irrational, right? Now every number you know is what? You already know natural number, whole number and integers, right? And now you study two types of other numbers, rational and irrational, right? So which means every number in mathematics, every number in the world that you know is either rational or irrational, which means it is either rational, and it is not rational, it is what? Irrational. Okay? So that means every number is either rational or irrational, right? So that means all the numbers together, okay? We're going to study a new thing, listen carefully. All the numbers together are called real numbers. All the numbers in the world, okay? All the numbers in the number system, okay? Number system means what? All the numbers in the world, right? So every number is a real number. Okay, so that is what we are coming to the conclusion. Okay, we are coming to the conclusion of what numbers are, what types of numbers are, right? So let me explain it to you once more. Let me summarize it for you. All the numbers in the number system, okay, all the numbers in the number system which we can represent on a number line are called what? Real numbers. Right? Or we can say, one more definition is there. What is the other definition? all the numbers, the collection of rational and irrational numbers, the collection of rational and irrational numbers, the collection of rational and irrational numbers together are called real numbers, right? All the numbers in the number system are together called real numbers, right? So any number you take in this world, any number that you know, okay, any number you take, it will either be rational or irrational, okay? It will either be rational or irrational. Now rational also has some subdivisions. What are the subdivisions? Natural number, whole number, integers, right? So when you look at a number, you will definitely be able to say whether it is an irrational number or whether it is a rational number, okay? So now keeping that in mind, let's go on to the next topic, which is suppose you have two numbers, okay? Suppose you have two numbers, 3 and 4, okay? Suppose you have two numbers, 3 and 4. What did I say? Suppose you have two numbers, 3 and... Now, in 3 and 4, how do we find a number that lies between 3 and 4? Can I find a number that lies between 3 and 4? Yes, I can find a number that lies between 3 and 4. How do I find it? Now look here, if I add these numbers, 3 plus 4 and divide it by 2, what do I get? 3 plus 4 is how much? 7 by 2, right? 7 by 2 is how much? 3.5. Divide and look, okay? If you don't know how to divide, please divide and look, okay? So anyway, 7 by 2 is 3.5. Now look here, 3.5, does it lie between 3 and 4? 3.5? Yes, and where does it lie? Right in the middle of 3 and 4, right? So that means if I take two numbers, I can definitely find a number between them, right? So this one, can I express it as, can I say the same thing as, one more example if I give you, 2 and 4. I want to find a number between 2 and 4. How do I find? 2 plus 4 by 2, right? I add the numbers and I divide it by 2. So what is the addition? 4 plus 2 is 6 by 2. What is 6 by 2? 3. So can I say that 3 lies between 2 and 4? Yes. And where does 3 lie? Right in the middle of 2 and 4. So that means if I have two numbers, I can find one number that lies between those two numbers, right? Now, can I say generally, instead of taking 2, 4 and 3 and all, can I say generally that if I take two numbers R and S, if I take two numbers R and S, R can be any number, S can be any number, right? If I take two numbers R and S, then I can find another number between R and S. What is the number between R and S? R plus S, R plus S by 2, right? That is what we did. 2 plus 3 by 2, that's what we did, right? 3 plus 4 by 2, that's what we did. So likewise, if I take two numbers R and S, I can find any number between R and S. What is the number between R and S? R plus S by 2. Okay, so this is the formula that we use to find a number between any two numbers. Okay. Now, keeping this in mind, can I generalize this and say the same thing for rational numbers as well? Imagine that R is a rational number, S is a rational number. So I can say that one rational number between any two rational numbers. Okay, one rational number between, where? In the middle of, between, right? So one rational number between any two rational numbers is given by this formula, is found by this formula. Which formula? R plus S by 2. So example, 2 and 4. Are these rational numbers? Yes, 2 is a rational number. Why? Because it can be written as 2 by 1, right? 4 is a rational number. It can be written as 4 by 1, right? So that means it can be written as 3 by Q, P by Q, which means these two are both rational numbers, right? So can I find one rational number between these two numbers? Yes, I can find. How do I find? 2 plus 4 by 2. Add the two numbers and divide them by 2, right? So what did I get? 2 plus 4 is 6 by 2, which is 3. I got 3. And 3 is another rational number. Yes or no? 3 is a rational number, right? 3 by 1. I can write it as 3 by 1. So 3 is another rational number. 3 by 1. So So that means I can find a rational number between any two given rational numbers. Okay. What is the formula? Just add the given numbers and divide them by 2. That is how we find a rational number between any two given rational numbers. Okay. So the next thing that we are going to see is next thing that we're going to see is in between any two numbers, say 2 and 6, can you find out how many rational numbers are there in between these two numbers? We cannot, right? So maybe you can, maybe you cannot, right? You can say some rational numbers like 3. Is it a rational number between 2 and 6? Yes, it is, right? 4. Is it a rational number between 2 and 6? Yes, it is. 5. Is it a rational number between 2 and 6? Yes, it is, right? So now, before finding out rational numbers between any two numbers, I want you to know a very small basic thing. Some of you might know, some of you might not know. So just please concentrate. Now look here. 0.5 and 0.512. Can you tell me which one is bigger? Which one is greater? Some of you might have identified, some of you might not know. So please look here. 0.5 is greater than 0.512. Why? Because when you have a decimal number, the more numbers you include here, the lesser its value becomes, right? The more numbers you write here, the smaller its value. So can I find a number that is smaller than this? Yes, just write one more number here and you will get a number which is smaller than that, right? So 0.5122. Is it a smaller number? Yes, this is smaller than this. This is lesser than this. Why? Because there is one more number. So which means the more numbers that I keep adding here after the decimal point, okay, the more its value becomes lesser and lesser, right? So now, next thing that you need to know is, next general thing that you need to know is, okay, if I take 1 and 1.5, okay, 1 and 1.5, can you tell me what are the numbers in between them? 1, after 1 comes 1.1, 1.12, 1.13, 1.14, etc, etc, etc. Then I can write 1.2, it comes between 1.5, right? And 1, right? 1.2, then 1.3, then 1.4, right? Likewise, in between these two numbers, I can say 1.21, 1.22, 1.23, right? Now, in between these two numbers, I can say 1.31, 1.41. So can you see that I can just write infinitely many numbers between 1 and 1.5? I can write infinitely many numbers, right? Now, look at another example. Look at another example. 2 and 3. If I want to write the numbers between 2 and 3, what are the numbers between 2 and 3? I can write 2.1, right? Or I can start with 2.01, 2.02, 2.03, then it will go on and it will become 2.1, right? Then it will become 2.11, 2.12, right? Etc. 2.9, right? Then, or I can write 2.2, 2.21, 2.22, 2.23, and then I can write from here also, under this I can write 2.211, 2.212, etc, etc, etc. So can you see that it just goes on and on and on? That means I can add more numbers here, more numbers here. I can add as many numbers as I want after the decimal point and keep making a lot of numbers that lies between 2 and 3. Did you understand? Yes? The only number that lies between 2 and 3 is 2.1, 2.2, 2.3, 2.4 and 2.5. Is it correct? No, it's not correct. All these numbers that come lies between 2 and 3, right? All the decimal points, all the decimal numbers that I take between 2 and 3, if I count, how many will be there? Infinite. There will be a lot of numbers, infinite numbers between any two given numbers, right? So from this we can conclude one thing. What is the thing that we can conclude? We can conclude that if we take any going to write a statement. Please look at this carefully. There are infinitely many rational numbers between any two numbers. There are how many numbers between any two given rational numbers? There are infinitely many rational numbers. There are infinitely many rational numbers. There are infinitely many rational numbers between any two numbers. Okay, that is what we wanted to conclude by telling about the decimal numbers, by telling about the numbers between any two numbers, right? So now in this class, what are the things that we have learned up until now? Let's summarize once. First of all, we started with what are perfect squares, right? And then we saw how to identify which numbers are irrational and which numbers are rational, right? The square root method, okay? Now after that, we came into all the collection, all the numbers in the number system are together called the real numbers, right? So every number that you take, any number that you take will either be rational or irrational, right? So that means real numbers is divided into two, what? Rational and irrational, right? And rational numbers is again divided into three, what? Natural numbers, whole numbers and integers, right? So that means, and then we came to this conclusion. What is the conclusion? Conclusion is that any two numbers you take, you can find infinitely many numbers between those two numbers. Okay, that is the conclusion that we came to. All right. Now the next thing is, now the next thing that we are going to study is how to find a particular number of rational numbers between any two given numbers. Okay, that's what we are going to find. Okay, that is where our exercise starts. Okay, so in tomorrow's class we will be doing exercise 1.1 because we have already covered all the parts in order to do exercise 1.1. Okay, and then we'll be continuing with the rest of the chapter from tomorrow's class. Okay, so make sure that before you come to tomorrow's class, before you start tomorrow's class and start doing exercise 1.1, make sure that you have watched these two videos and made everything clear. All the concepts should be clear in your mind. Only then you'll be able to do. Exercise 1.1 is a really easy exercise. It's a very scoring exercise if some question from those exercises come. So make sure that all these concepts are clear. Only then whatever I'm teaching you tomorrow will be clear to you. Alright? So make sure that you watch these two videos and have a good day ahead. Alright? Thank you.